So now what we're going to do is we're going to calculate the energy in joules of electromagnetic radiation with a wavelength of 477 nanometers. There are two equations that we would use. So the energy equals h times frequency. That's one of the equations we need. And the other one is the one we used last time, that the speed of light equals wavelength times frequency. And so we are looking for energy, and we have wavelength. So what I'm going to do is I'm going to actually combine these two equations. These two equations, by the way, are the equations that are on the conversion and equation sheet. However, if I solve this equation for frequency by dividing it by wavelength, so these two are the same thing except rearranged. And instead of frequency, I now plug in.
Don't press nothing.
Instead of frequency, I now put in C over wavelength. I get an equation that relates wavelength to energy. And we can see longer wavelengths, so bigger numbers down here, will lead to lower energies. And that's what we said before too. But now let's actually plug in. So Planck's constant is given on the conversion and equation sheet. It is 6.626 times 10 to the minus 34th joule seconds. The speed of light is 3.00 times 10 to the 8th meters per second. And the wavelength is 477 nanometers. Now, I have meters in my problem, and but I have nanometers in my for my wavelength, so I do have to convert this into meters. We know that 1 nanometer equals 1 times 10 to the minus 9th meters. That's a minus 9 there. And so what I'm going to do is I'm going to write 477 down here. And instead of the nanometer part, I'm just going to write the times 10 to the minus 9 meters. It's like this part is the same as the nanometers. I apologize if this is a little out of focus. Now, now all that's left to do is the math. So I have 6.626 times 10 to the minus 34th times 3 times 10 to the 8th divided by 477. And you can just go straight to 477 exponent 9 minus. And if you do that, you get 4.167 times 10 to the minus 19. And my meters cancel, my seconds cancel, and I'm left with just joules. And this is one of those, thankfully, multiple choice questions. And it looks like my answer is going to be times 10 to the minus 19 joules. Yeah.
I have a question, Professor.
Go ahead, Mohammed.
Yeah, for the 6.62, 6 and 3.00, are they constants or you have to find them?
They are constants, and they're
Okay.
both on your conversion and equation sheet.
Mm.
So
Okay. All right. Thank you.
yeah, so actually they're right next to each other right here.
Okay. Okay.
Yeah.
Thanks.
Any other questions?